Hey guys, this is the second video and the last one for this particular unit. I told you it was super short. So last video we talked about the moon, the sun, and the earth as a system and that it causes lunar phases, what we get to see from earth based off of what's reflected off the moon. Now, we've got these bodies in space that are moving around, and so we got to bring in a little bit of Newton's laws and a little bit of force, motion, and energy. So this is called lunar cycle and tides. It's the impact of gravity. So we know that we have these objects in space that are moving around. We've got the Earth that rotates and it also revolves, and now we know that the moon rotates and also revolves around the Earth. Well, each one of these bodies, including the sun, has gravity. And gravity is that invisible push or pull that we talked about in the force, motion, and energy unit. So all objects attract other objects with the force of gravity. Remember that Newton's law of action and reaction says for every action there's an equal but opposite reaction. So the moon is going to exert a force on the earth and a force on the sun, and likewise those bodies are going to exert a force back the other direction. But the deal is that bigger objects are going to exert more gravity than smaller objects. So the sun's gravitational pull is actually going to be greater than the earth and the moon due to its sheer size. That's why the moon and the earth are able to revolve around the sun. That's also why the other planets are able to revolve around the sun, because it has such a great gravitational pull. At the same time that we're looking at the mass of an object, we're also looking at how close the objects are together. Because the moon is closer in distance to the Earth's gravitational pull is going to have a greater impact than the sun's gravitational pull on the moon. So I've drawn you two pictures, three objects, the moon, the earth, and the sun. And the amount of gravity is going to increase as you go from moon to earth to sun. So what kind of impact does this have on the Earth's surface water? Well, that's where we're going to get our tides. Tides are the regular rise and fall of Earth's large bodies of water. So this could include things like lakes, but then also the ocean. And tides are basically caused by the gravitational pull of the moon and the sun on the Earth's water. Tides are going to result from unbalanced forces. Remember that unbalanced forces, we have to have a net force that's greater than zero. It's also a transformation between potential energy and kinetic energy, so constantly going back and forth and back and forth. Each location is going to have two high tides and two low tides experienced daily. The difference in the location on Earth is going to dictate how obvious those high tides and low tides are going to be. Now, sometimes the sun and the moon and the earth are going to line up in a specific way, and so their gravitational pulls are going to act together. You'll see in this picture that we call this first one a spring tide, and you'll notice that the sun, the moon, and the earth are directly in line with each other, so 180 degrees. This means that all of the gravitational pull from the sun plus the moon is going to react together, and they're going to pull the ocean on the side closest to both of those bodies. Well, we know from our lunar phases video that the moon and the sun and the earth are in line 2 times during a lunar cycle. So during the new moon and the full moon, all 3 of those bodies are going to be lined up, and we're going to have a great amount of water, or what we call a tidal bulge, on the side that's in conjunction with both of those. And then as an action or reaction portion, we're going to have a tidal bulge on the other side. Now, during 2 other times of the lunar cycle, the sun, the earth, and the moon are going to make a right angle. And when it does so, during the first quarter and third quarter, we don't have quite as much gravitational pull on the Earth's surface water. So we end up getting something called a neap tide, where the 2 gravitational forces of the moon and the sun do not act together. So there's less of a tidal bulge on each one of those sides. Now here is a picture to show you week 1, 2, 3, and 4. And with each one, what does the difference look like in the high tide and low tide for spring and for neap? You'll notice that with spring, you have a huge difference between high and low, and for neap, there's very little difference. And that, my lovelies, is a tidal wrap-up.